So this will be somewhat new, except for we're just combining everything we've learned so far. Often you will be given a polygon with diagonals inside. The resulting shapes are triangles, trapezoids, or pentagons. I'll make a note. We will only deal with regular polygons on the outside. This might make more sense later on. And so let's look at those shapes. So isosceles triangle, and then I'll kind of make a dashed line like this, and it might get longer yet, but I'm going to have 3 columns here. You have an isosceles trapezoid, and then a line here, isosceles pentagon. Yes, there are such things as isosceles triangles, trapezoids, and pentagons. Okay, they all have similar properties. So consider a triangle. For it to be isosceles, these two, or there have to be 2 sides that are congruent, right? And it's the angles across from the sides, we're going to call them B, that they're both the same. That's why we give them the same letter, because it's the sides across from the congruent sides, right? The angles across these congruent sides are going to be congruent also. And the one that isn't, we're going to call that A for us to be consistent here. And let's go over to the isosceles trapezoid. A trapezoid is a four-sided, it's a quadrilateral, it's a four-sided shape. Okay, and it will have these 2 sides the same, as well as the top. And if that is the case, it's these base angles here that are going to be congruent, right? The top doesn't necessarily need to be congruent, but it's the sides here. You will see that the top will also be for what we're doing. but it's the angles across these congruent sides that are the same, and the ones that aren't, or that are different, we're going to call those A at the top. And this one might be a little, it's a pentagon, so just start with a roof maybe, like this, and then we'll go in just a little bit, like that. And so these sides are all going to be congruent, and you'll see why I'm doing that for our purposes. And so the two base angles here are the same as well. And notice that this base side here is, I never make the bottom congruent to the rest of the sides. That's important to note, right? These are not the same as everything on top. We know that sum of a triangle, the interior angles always adds up to 180. Sum of any rectangle, it doesn't matter what shape it is, it's always 360. And this can be backed by the formula of sum, right? Sum of a pentagon is going to be 540. Because it's 5 minus 2, right? That's 3. 3 times 180 is 540. I just confirmed it here, so I'm not giving you the wrong. Right? So we know the sums of each one of these if you were to add the interior angles. So that is very helpful, because to find B, in this case, we would go like this. B is found by taking the sum, subtracting A, all of that is going to be divided by 2. Because if you subtract A from 180, then you split the remainder in half and give each side half of it, right? So these are definitely worth adding to your study sheet. If you wanted to find what B would have to be in this case, you start off similarly. We go 360 degrees, and here we start with 180. And in this case, you have two A's. You got to subtract those two angles, so we go 2 times A. All of that still divided by 2. Make sure you put the top in brackets, because I see a lot of students not putting them in, and they type it in all in one shot, and then you get it wrong. And then the last one, if it's a pentagon, it's 540 minus, there are 3 A's up here. So you go minus 3A, all of that still divided in 2, because we split that remainder in half. And though there aren't any more, so this is where we kind of stop here. So I would say this section right here, you should add to your study sheet. Okay, definitely. Make it smaller, or you might not even have to have the diagrams on there, but just when it's a triangle, when it's a trapezoid, when it's a pentagon, those are the formulas that are going to help us here. Okay, so let's do some calculations using that. Calculate the values of A, B, and C. Show work and explain. work, explain. All right, Alex. Okay, and here's where, what is this? 1, 2, 3, 4, 5. This is a hexagon. Okay, so I'll help you draw that hexagon as best as I can. So it has 3 sides. So it's almost like 2 trapezoids put together. There you go. And then we're gonna add a diagonal to this. Are you ready? So I'm gonna use my ruler. I'm gonna use a different color. I'm gonna connect this corner here to that one right there. So it sticks out. That's your diagonal. And then we're gonna put down, this is really small. Should have made it a little bigger, but A goes there in that corner up top. See that small lowercase a there? We're gonna put B here, and C is here. So A, B, and C. Hope you can see that. Okay, I'll give you a little bit of notes here for this. What are we at? 250. Okay. We will focus on the exterior shape first. A lot of students want to dive right in there. It's like, no, focus on the outside. What's wrapping around this whole thing? Okay. So hexagon, that tells us that n is equal to 6. Find the interior angle using I of n is equal to n minus 2 times 180 over n. So I of 6 is going to be 6 minus 2 times 180 over 6. That's 4 times 180 over 6, which is 120. I would just start with it, like without even going further. So you found the interior angle of this because that's your starting point, right? And then you look at A, and if you know what an interior angle is, you would recognize that A is an interior angle of the polygon on the outside. So A is going to be 120, and I'll just put a note there, happens to be the interior angle. Just don't get too fixated on the variables I gave you up there, right? When I gave you I'm just going to scroll down just a little bit, like, don't think, oh, it's A, I have to plug that in here. Look at what does A represent in this situation, right? That's what you need to look for more than anything. Okay, so we've got that taken care of. Then I'm going to focus on this, on B. Okay, B is the base angle of an isosceles. Oh, isosceles capitalized, right? Isosceles triangle. And so what we're going to do is, therefore, three dots like that. B is going to be 180 minus 120 over 2, which is 60 over 2, which is 30 degrees. And because I kind of made it very small, so I'm going to take that triangle and redraw this here for you. This is 120, and this is B. We know that these two are the same. By the way, this is a regular. So can you go back to the original? Like, I can guarantee you that this will only be done with a regular outside shape. Okay. So if you take that triangle from up here, we know that the two, like the roof, so to speak, measures the same. So we know that, right, these angles are the same. If you found this B, it's also the same thing as finding the one across here. So when you found B and it was equal to 30, we used that property here. Now we need to find C. C is equal to interior angle minus, interior angle of hexagon, I will say, of hexagon minus B. So just write that down, let that sink in. Let's finish that question and then I will explain that. So we know that B and C make up the interior angle of that hexagon. So we know that the whole thing is 120 here, right? The whole thing here is 120. So if you subtract B from the 120, we would get angle C. So angle C is 150 degrees. This would, you don't have to explain in like sentences like this. Just doing the work and maybe adding some terms here and there is all I need, right? That's all I need. So we found C, we found B and A, okay? But I will just focus on the exterior shape first and find the interior angle. That's almost a given that you're gonna need to do that anyways. Question? Oh, yeah. Sorry, is that 90? That should be 90. I'm adding instead of subtracting. Thank you. Vincent, right? Yeah. Sorry. Oh boy. Did somebody online say the same thing? Oh, okay, no. Alex just said. Okay. Sorry, it's 90. And it does kind of look like a 90, even though it didn't draw to scale. Okay, let's do one where you have, I'm going to go to the octagon here. So let's try our best to make an octagon here. So I'm going to start here, here, here. So it kind of starts like a trapezoid, but then you have, it's like a stop sign, right? There we go. And the diagonals, I'm going to use a different color for it. So I'm going to connect this with that, like that. So that's a diagonal. we're going to call this B up here. We're going to call this A here. C. By the way, this C, yeah, I'll put it here, but I was thinking maybe putting it there. It doesn't matter. Let's put it there for now. C is there, and then watch this move. I'm going to extend dashed lines and extend that side and this side, and they're going to meet like this. And I'm going to call that D. It kind of looks like a 90, but we'll find out for sure if that is a 90 indeed. So don't assume, okay? So you should see, whatever color you use, you should see the octagon clearly, right? And then the diagonals and something that maybe goes out of it with a dashed line, but you should still see the octagon, okay? N is equal to 8. I'm going to go ahead and find the interior angle. And it's 8 minus 2 times 180 divided by 8. That's 6 times 180 divided by 8. And that is 135 degrees. And then you look. Okay, Nico. You look at 135 and look, see, because you found the interior angle, and B right here happens to lie on an interior angle. Okay, so B is equal to 135 degrees. You're done answering B. There we go. Interior angle of octagon. So I kind of just borrow this, thank you very much, right? And just plug it in there. I purposely made that B so you're not, right? So you're not thinking, oh yeah, it's always A. It's like, not really. The order doesn't matter. Then you can look at A here. If you wanted to find A, there's no way you can do that without realizing, I will do this for you. Go ahead and do the same. This is a 1, 2, 3, 4, 5. This is a pentagon here. Isosceles pentagon. So we're going to bring this out. It's an isosceles pentagon. So angle A would be, pentagon tells you that that the sum is 540. Right? That's what you should be thinking of. So we're going to go 540 degrees minus, in this case you have to be careful. I'm going to use a different color. Watch what I'm going to do on my original. The 135 I found is the interior angle of this octagon. So I know that this is 135. I know that this is 135. 135, right? Like these three angles up top, like the roof, it's almost like a barn roof, right? They have three angles up there that measure 135. So we're going to go minus 3 times 135. And we always divide it by 2. You have to be very careful here. So I'm going to go, I don't have my fancy calculator now, but I'm just going to use this one. So the top is 135, and then you divide it by 2. which is 67.5 degrees. So you just found, ladies and gentlemen, like if you pay attention, you found A, which is 67.5, but you actually also found that this is 67.5. That's why you're splitting it in half, because this is an isosceles pentagon, and you wanted this angle, and that is 67.5, but you're also knowing that this is 67.5. And if you were to add up all the angles, it should add up to 540 degrees in that pentagon. So it's now you know what I mean by inscribed. You have a shape inside another shape. Okay, so you have your octagon, and then you have a pentagon. And some of you might be asking, Mr. Dirksen, isn't this the exact same? It's like 1, 2, 3, 4, 5. Aren't these exactly the same? Yes, they are. Yes, they are. And you will find out now to find angle C is going to be interior angle minus A. So angle C is going to be, what's the interior angle again? It's 135. 135 minus A, which is 67.5, and that is 67.5. So in this case, it just happens to be the same. But never assume, because these shapes, they change all the time. And I think what I will just do is highlight the 135, and then back to here, 135, and then back in here, right? Like how the interior angle is used everywhere. That's why I ask you to find it right away, because it will be important to know. Okay. Last one is D. We need to figure out D here. And see. And I'm going to do this the following way. We know that this is 135 here. So what is this little angle going to be? It's going to be the supplement, right? Because interior, exterior, this is going to be 45 degrees. And since you have 135 here in this corner, right, this is also going to be 135, no, 45, sorry, 45 degrees right there. And so D, where do I do this so that you have it nice and organized? I'll just keep going down here. D, angle D is, this is a triangle, right? The little sliver that sticks out is a triangle, so it's going to be 180 minus 2 times 45, which you know is 90, right? 2 times 45 is 90, so 180 minus 90 is 90 degrees, which we kind of suspected anyways. But it's not always going to be. Please don't think like, I'm not going to do the work, I'm just going to guess that it's 90. These shapes, I'm going to use different shapes all the time, and these numbers change, okay? I skipped trapezoid, folks, because I didn't know if I was going to have enough time. And what do I mean by that? I'll show you. Like, we didn't use this, but as I say, like, you can use either one of these depending on what shows up on your pentagon or hexagon or heptagon, you name it, right? I will ask you to do page, remember the one you couldn't do, so page 31, question 17, B and C. Page 33, to 34, there's one with inscribed shapes that I'm looking for, like actually inscribed. There it is. Yes, page 14. I'm pretty sure I have the answer key to all of these, so I will be posting them. I'll be posting the keys later on.